Welcome. Today we'll solve an integration problem using partial fraction decomposition. Let's integrate the function x plus 4 divided by x squared plus 2x plus 5 with respect to x. First, let's examine the denominator. The denominator x squared plus 2x plus 5 can be rewritten as a perfect square plus a constant. To complete the square, we take x squared plus 2x, add, and subtract the square of half the coefficient of x, which is 1 in this case. Now our integral becomes the integral of x plus 4 divided by the quantity x plus 1 squared plus 4 dx. For this type of rational function, we can use the method of partial fractions with complex denominators. The denominator can be factored as the product of x plus 1 plus 2 I times x plus 1 minus 2I. This suggests we should decompose our fraction into a over x plus 1 plus 2I plus b over x plus 1 minus 2I, where a and b are complex constants. After solving for a and b, we get that a equals 1/2 plus I over 4, and b equals 1/2 minus I over 4. Substituting these values back, our integral becomes the integral of 1/2 plus I over 4 times 1 over x plus 1 plus 2 I plus 1/2 minus I over 4 times 1 over x plus 1 minus 2 I dx. The integral of 1 over x plus is the natural log of the absolute value of x plus a. Therefore, our solution is 1/2 times the natural log of the absolute value of x plus 1 plus 2 I plus 1/2 times the natural log of the absolute value of x plus 1 minus 2 I plus c. This can also be written as the natural log of the square root of x plus 1 squared plus 4 plus c, which is our final answer. To verify this is correct, we could differentiate our answer and get back to our original function. The key steps we used were completing the square, partial fraction decomposition with complex factors, and integration of basic logarithmic forms.